Alright, here we go with part 2 of how to learn the chain rule. Okay, so I had written down the rule in my first video, and I want to go ahead, just so that it's handy and we're looking at it, I want to go ahead and write it again. So the chain rule is the rule that you would apply to a function of the form y equals u to the power n, where the u will be probably a function of x, a formula that involves x, or it could be involve another variable, whatever, but the u is some other formula, some other function. And the derivative of this sort of thing is n times u to the power n minus 1, then times du over dx, where the du over dx is the derivative of u with respect to x. Okay, you might also think of that as u prime. So there's our rule. Now I want to work some problems in this video that are a little more difficult than what we would have seen in the first one. Okay, now this one is not more difficult than the ones we would have seen in the first one, but we need to agree about how to do this one in order to do this example, which is a little more difficult. Okay, anyway, so well, let's see. Function is x plus 1 to the third power. So far that is like this. It's x plus 1, that would be like the u, to the third power, that'd be like to the n. It's a function raised to a power. And I want f prime. F prime is a notation for the derivative. This would be the rule to find that. Now, all right, f prime is, let's see, bring the power down, 3 times u, which is x plus 1 in this case, subtract 1 from the power, that becomes 2. And then what goes here is du over dx, or it's the derivative in this case of x plus 1. But that would just be 1. So that's how this rule plays out for this initial function. Now, it's like, obviously I can express the answer to this simpler. I don't need to write the 3 and the 1 separate. 3 times 1 is 3, so 3 times x plus 1 squared. Okay, and so there's my derivative. Now, I would need to know that to do this problem. The derivative of x plus 1 to the third power times x plus 5 to the fifth power. Because x plus 1 to the third power is part of this, okay? And so we know how to do that now. Now, the derivative of x plus 5 to the fifth power on its own wouldn't really be any different than this, all right? But we would have to know the derivatives of these two things individually to find the derivative of this entire function. The reason is because this is a product, okay? It's the product of two functions, right? It's x plus 1 to the third, that's one function, times, separately, x plus 1 to the fifth power, x plus 5 to the fifth power. That's another one. It's a product of two functions. So in that case, we use the product rule. All right. Product rule says if y is one function f times another function g, then the derivative of that is f prime, meaning the derivative of that first function, times g, the second function the way that it is, plus g prime times f. The derivative of that second function times the first function the way that it is. So I'd have to do that. But the way that I would find the derivatives f prime and g prime along the way here would be by the chain rule as I showed you up there. Okay, so let's try to do this one with all of that in mind. Okay, so f of x is here. I want to find f prime. All right, so here's f prime. Derivative by the product rule of the first times the second plus the derivative of the second times the first. Okay, derivative of that first function is 3 times x plus 1 squared, okay, times the second function, x plus 5 to the fifth power. Okay, so that's f prime times g. That's the first part of the product rule. Then plus, right, g prime. So what's the derivative of x plus 5 to the fifth power? That really wouldn't be any different than working this one out. Okay, but the derivative of x plus 5 to the fifth power is 5 times x plus 5 to the fourth power. So that's g prime. And then times f. Okay, so there it is. There's my derivative. I used the rules the way they're supposed to be used. That's the derivative. If so, if this was a revenue function, this would be the marginal revenue. Okay. Okay. Now, I guess the only other matter is, could I simplify this? Could I reduce it? Does it have to have so much stuff in it? And the answer to that is, yeah, I could actually reduce this. So it's here's an analogy. Could you reduce somehow, let's say like basic algebra problem, a squared times b to the fifth power plus b to the fourth power, a to the third power. So it's something like that, able to be reduced. So yeah, you could factor it. You could reduce it that way. Like, so for example, like each of these two terms has a common factor of a and b. In fact, like the most a's that you have in common are 2, right? Because this has 2 a's and this has 3, so there's 2 in common. And the most b's you have in common is 4, because this term has 5 and this term has 4, so you got 4 in common. If I factor that out, I'll get b. Take away 2 a's and 4 b's, that'll leave me 1 b left over, plus, okay, and then if I take away 2 a's and 4 b's from this one, I'll get that. I'll get a left over. So we could do something like this and at least get it a little simpler. Okay, so let's try it. So here's on our road to the simpler form of our answer right here. So okay, I could factor out 2 x plus 1s, because I've got 2 here and 3 there. And then I could factor out 4x plus 5s, because I got 5 here and 4 there. Now, besides the 3, like 3 is not common to each term, and in the 5 is not either, so I have to leave those. But from this first term, 3 times x plus 1 squared times x plus 5 to the fifth power, if I take out 2x plus 1s and 4x plus 5s, I'll leave behind a 3 and an x plus 5 to the first power. Okay, so that's what's left in this first term if I take this away. And I got my plus here. So again, with this second term, if I take away 2x plus 1s and 4x plus 5s, what's going to be left over? I'll have a 5, and I'll have 1x plus 1. Okay, alright, so that's the kind of thing that I was wanting to do. It's like this, really. Now, it will simplify a little bit from here. Okay, so I did this factoring part thinking that that would lead me somewhere. And where it leads me this time is that, well, this stuff in here can be combined. Okay, now I don't want to rewrite this whole thing just for me to tell you about this part. But this part and those terms can be combined and reduced and simplified. Like if you multiplied the 3 through there and multiplied the 5, then you get something that looks like this. 3x plus 15. Okay, that would be that part. And then over here you'd get plus 5x plus 5. Okay? Alright, and then so yeah, we could do some combining across the board in there, right? We'll get 8x, 3x and 5x, plus 20. Alright. Now, this will probably be good enough for my math lab. Okay? I mean, I cannot say that all the time, everywhere that you're doing your homework or your practice, that the answer will always be acceptable in one way or the other, but I think that this will probably be fine. And we have x plus 1 squared, x plus 5 to the fourth power, and then we said all this reduces to 8x plus 20. Okay, so that's probably okay. So I'll give you this as my answer. Now, I'm not 100% certain that this will be acceptable because there is one more simplifying thing that you can do. Like, for example, out of these two terms, 8x and 20, we can factor out a 4. Right? Because, 2 times 4, that'd be 8, and 5 times 4 is 20. So, I mean, that's one more thing that might be necessary. So I'll show this to you. And, I don't really know what's acceptable all the time, everywhere, like I said. But, let's say if I factored out 4, then I would get 2x plus 5, right? 4 times 2x, that's 8x, and 4 times 5, that's 20. And then I would have it out here like that. Okay. So I'll give you both of them just to hedge my bets a little bit. Okay, so try this if you want to. And if you find that's not working, it's just because there's some extra factoring, some extra reducing that we can do. Okay. Now, that's how that one would work, with some possibilities for exactly how we write the answer. That will almost always be the case in math. The last simplification might be a matter of judgment, all right? But you're aware of how these two answers are equivalent. That, at least, I want you to see. So let's try one more that was a little bit of a challenge. Okay, there's this one. Okay, 2x plus 2 to the 5th power times the square root of x. Now, I wanted to compare this one with the one we had done a minute ago, because it's also a product rule. Okay, but how about this? When I use the product rule, I'm going to have to find the derivative of this first function times the second one as it is, plus the derivative of the second times the first. That's the way the product rule works. Product rule is f prime g plus g prime f. So how about I work that out ahead of time? Okay, let's see. Let's do like this. So here's some shorthand. The derivative with respect to x of 2x plus 2 to the 5th power, I would find that derivative by the chain rule. Okay, because it's u to some power n. So here's my notation. Says I'm finding the derivative with respect to x. That means that the variable is x in there. And it is otherwise a chain rule type problem. So our derivative is 5 times 2x plus 2 to the 4th power and then times 2. So I'll get the derivative of this first function right there is 10, because I've got a 5 and a 2, times 2x plus 2 to the 4th power. Okay, so when I use the product rule in a minute, this will be one aspect of it. The next thing I need to know is what's the derivative of the square root of x? What's the derivative with respect to x of the square root of x? And again, the problems like that are covered earlier with earlier videos and material and assignments and so on, but it would be 1 over 2 root x. Okay, so now this is enough to apply the product rule to this. Okay, so all right, here's where I'm going. I'm going to apply the product rule to this to find this derivative. Okay, I get my y prime. So f prime 10 times 2x plus 2 to the 4th power times g, which is root x, plus g prime, the derivative of this, but that's 1 over 2 root x, times f, 2x plus 2 to the 5th power. Okay, so now I'm here, and there's my derivative. That's it. That is the derivative of this function. Okay, like every problem, we can get the derivative in one step. This is y, the original function. This is y prime, the derivative, telling you all the things that the derivative tells you. If this was revenue, this would be the marginal revenue. If this was cost, this would be the marginal cost, and so on. It's just a matter of simplifying it, making it as presentable as possible. So let's see. what I think would be customary for this type of function is to add these terms together, but then again, one is a fraction. Okay, so here's what I'll do. If I want to add this to this over here, I'll need to get a common denominator. It's like, if you want like a much simpler analogy, it's sort of like if I was saying, what's 3 plus a half? Well, if I, 3 is a whole number, 1/2 is a fraction. If I was going to add those together into one thing, then I would have to get a common denominator of 2, okay? So I would have to write like this: 6 over 2 plus 1 over 2. Obviously 6 over 2 is 3 anyway, but this now makes it compatible to be added with a fraction. So I'll get 7 over 2, okay? Now I need to do something like that. Well, this one, because this is like the whole number and this is like the fraction. So to get an LCD, the lowest common denominator is 2 root x. So what I would have to do is, like I did here, I multiplied 3 over 1 by 2 over 2. That's how I got 6 over 2. So here, to get that common denominator, 2 root x, I'd have to multiply 2 root x on the top, 2 root x on the bottom. If I did that, here's what I'll get. I will get 20 x times 2x plus 2 to the 4th power. So think about that for a second, and then I'll explain more about what I have right there. Okay, the 20, where'd that come from? Well, 2 times 10. The x, where'd that come from? Well, I got root x times root x. That would be x. So that's how I get 20x. Then obviously I get the 2x plus 2 to the 4th power, and then there's my common denominator. Now I'm going to add that to, well, this fraction amounts to 2x plus 2 to the 5th power. That's on top, that's over the bar. You could imagine there being a 1 under that if you want to, times 2 root x. Okay, so there's the fractions I'm looking at with common denominators like I need. So I could just add now the top over the common denominator. So here I'm a little closer to the answer, not all the way there, but close. So let's see. Let's say, alright, if I take this and I add it, I get 20x, 2x plus 2 to the 4th power plus 2x plus 2 to the 5th power over 2 root x. Now this part, it's a little bit like the problem we just did, where with these similar things and their exponents, there are some common factors to the two terms. So here it's like I got 2x plus 2 and 2x plus 2 in both terms. I have 4 of them here and 5 of them there. So like that does mean that I could factor and probably simplify just like the one we did before this. Okay, so well, let's just look at the top part. So I won't rewrite it to just do this, but just the top part. If I could take out 2x plus 2 to the 4th power. Okay, so I'll do 2x plus 2 to the 4th power because that's the most that these two terms have in common. And then I'll get a 20x left over from this first term if I take away 2x plus 2 to the 4th power. And then over here I'll get 2x plus 2 to the 1st power, okay? Which I can just write as 2x plus 2. So, I mean, I guess on the top then, I factor this out. This is what's left when I'm done with that. And then I get 2x plus 2. But with adding here 20x and 2x, I'll get 22x plus 2. Okay, and then that part, that's reduced. So let's see. Let's do this. I'm gonna change pins. Y prime. Alright, so here we go. Looks like I'll get 2x plus 2. 22x plus 2 over 2 root x. Okay, so I think again, MyMathLab will probably accept that as okay. But just in case, here's another thing that may at some time be required, or that you may need to know. There are a lot of 2's up here, and I guess I could reduce it a little more. Like, say I could factor, see that has 2x plus 2, like there's a common factor of 2 in there. And over here too, 22x plus 2, I could factor 2 out there. So it might be that if I perhaps need to go any further, then I could write this top part as 2x plus 1 to 11x plus 1. And then I've got, either way, I've got a 2 over a 2. So say if I picked either one of these and canceled with that one, there would just be one left. And so I would say, well, okay, I would get something like this with that extra canceling. Okay, that would be the top. And with, say, this 2 and that 2 canceled, I would just have this left over. Alright, so as I've been saying in the other problems, it's a little bit of a strange thing about how far exactly to go when you cancel and reduce and simplify. You would want to do the obvious things, but you know, here it could be a toss-up, so I'll put or, whoops, and I really just wanted you to know about either of these and how one can be gotten from the other, just in case. Really, so I'm telling you that just in case, so you'll know it if you need it.